Hello. In this video, we're going to be talking about right triangle trigonometry. In particular, we're going to be talking about the 6 trigonometric functions. The 6 trig functions are the sine, cosine, tangent, cosecant, secant, and cotangent. We're going to be defining each one of those 6 functions as ratios of two sides of a right triangle. So let's talk a minute about a right triangle. So we've got a right triangle drawn here. The little square in one of the corners represents the 90-degree angle, the right angle. And I've also listed theta in here, one of the two acute angles, because theta is going to be the input to our 6 trig functions. All right, so I said we're going to be defining the 6 trig functions as ratios of two sides of this triangle. Well, we need a way of identifying the sides. So the first side we'll identify as the hypotenuse. The hypotenuse is the side that's opposite the right angle. So locate your right angle, go to the side opposite it, and that's the hypotenuse. The other two sides are identified from the perspective of angle theta, the input to the trig functions. So if you find theta, go to the side opposite theta, and we'll call that, surprise, surprise, opposite. Then that leaves one more side, and that side is the side that's not the hypotenuse, but is touching angle theta. So that is going to be called adjacent. Okay, so we've labeled all 3 sides of our triangle. So let's start defining our trig functions. So we're going to define the sine, cosine, and tangent first. Those are the ones you're going to be dealing with most frequently. So the sine of theta is simply the ratio of the side opposite theta, so the length of the side opposite theta, over the length of the hypotenuse. The cosine of theta is defined as the length of the side adjacent to theta divided by the hypotenuse. And the tangent of theta is defined as the length of the side opposite of theta divided by the length of the side adjacent to theta. And notice when I wrote these definitions, I wrote sine theta, cosine theta, tangent theta. You have to have that angle there so you know from what perspective you're defining these 3 trig functions. So don't ever forget to write your angle. All right, so let's talk about a little memory aid here. You may have seen it before. It's called SOH-CAH-TOA. It's just a little mnemonic device. So where that's coming from is sine is opposite over hypotenuse. So that's your SOH. Your SOH. Then for cosine, we have cosine is adjacent over hypotenuse. So that's your CAH. So CA. And then lastly, we have tangent is opposite over adjacent. So that's your TOA. SOH-CAH-TOA. So it's just a little mnemonic device to help you remember these ratios. Okay? All right, so let's do a little example here. So I have a right triangle. There's my right angle. Here's my theta. For this particular right triangle, this side has a measure of 5, this one has a measure of 12, and this one has a measure of 13. So I want to find the values of sine, cosine, and tangent of theta. So sine of theta, remember, so sine is opposite over hypotenuse. So if I look at theta, opposite angle theta is 5, and the hypotenuse is opposite the right angle, so 13. All right, one down. Cosine of theta, so that's our CAH. Cosine of theta equals adjacent over hypotenuse. So look to your triangle. The side touching theta but not the hypotenuse is 12, so that's my adjacent. And the hypotenuse is 13, so that's the cosine of theta. Cosine of theta is 12 over 13. And lastly, I've got the tangent of theta. So TOA, opposite over adjacent. So we've already identified the side opposite theta is 5, and the side adjacent to theta, but not the hypotenuse, is 12. So we found our three primary trig functions, the sine, cosine, and tangent of theta for this particular right triangle. So we've got three more trig functions. Let's go back to our original drawing here. Cosecant, secant, and cotangent. So we can define these as the ratio of two sides as well, but another way we can think of cosecant, secant, and cotangent is in relationship to sine, cosine, and tangent. So sine and cosecant are reciprocals of each other, meaning sine of theta equals 1 over cosecant theta. Or you could say the cosecant of theta equals 1 over sine of theta. They're just reciprocals of each other. Cosine and secant are reciprocals of each other. Tangent and cotangent are reciprocals of each other. So what we're going to do is we're going to use these reciprocal relationships to figure out the values of the cosecant, secant, and cotangent for the triangle we were working on. So here's a summary of what we just did for our triangle that had sides 5, 12, and 13. So now what we want to do is we want to figure out the cosecant of theta. We want to figure out the other three trig functions. So the cosecant of theta, remember we said cosecant is the reciprocal of sine. So if I look at the sine of theta, it's 5 over 13. So its reciprocal is just 5 over 13 flipped. So it's 13 over 5. So now we found the cosecant of theta. And you can see what this means as well, 13 over 5. That means you can think about cosecant also as the ratio of hypotenuse over opposite. Hypotenuse over opposite. So you can also think of it that way. All right, cosine is the reciprocal of secant. So secant theta equals 1 over cosine theta. Cosine theta was 12 over 13. So if I flip that, I get secant theta. Tangent and cotangent are reciprocals. So if I want to find cotangent of theta, I think about the reciprocal of tangent. Tangent is 5 over 12, so its reciprocal is 12 over 5. So now we found all 6 trig functions for this particular right triangle. Okay, I want to spend just a minute here talking about orientations of these right triangles. Orientation doesn't matter. You just have to be careful to label your sides correctly. So what I want to do here is just take a minute, and relative to theta, I want to label the sides of these triangles. So if I've got this one, so it looks kind of upside down or sideways relative to the one we were dealing with before. So if I want to label my sides so I can find my 6 trig functions, I do it the same way I did before. Opposite the right angle is my hypotenuse. Opposite my theta is my opposite side. So opposite theta is opposite. And then touching theta, but not the hypotenuse, is adjacent. So the orientation's different, but the concepts are all the same. So let's do a couple more. So here, we'll do this one. So same process. Opposite the right angle is the hypotenuse. Opposite theta is opposites. Touching theta, but not the hypotenuse, is adjacent. Okay, one more. So here I've got one where the hypotenuse is actually at the base level. So if I look at my right angle, opposite my right angle is my hypotenuse. So it's on the ground. So theta is, if I look opposite theta, that's my opposite side. And then I've only got one other side left, and it's touching theta, but not the hypotenuse, so that's adjacent. Okay? Okay, one more little point I want to make before we leave this. Again, we've been defining our sides relative to theta because we've been looking at sine theta, cosine theta, etc. Theta has been the argument of our trig functions. So say this was our 5, 12, 13 right triangle. So this is the same triangle. So we already figured out that the sine of theta is opposite over hypotenuse. So opposite angle theta is 5. The hypotenuse is opposite the right angle, so that's 13. But what I want you to notice here is same exact triangle. But now I want to know what's the sine of beta? Beta. So now what we have to do is we have to define our sides relative to beta. The trig function is still defined as the ratio of opposite to hypotenuse, but it's the side opposite beta. So if I look opposite beta, what's that? That's 12. My hypotenuse is the same because that's opposite the right angle. So that's still 13. But notice 12 over 13 instead of 5 over 13. So that's why I was making the point earlier, you have to be really, really, really careful to write the angle as the argument of your trig function so you know what you're talking about. If you just write sine equals 5 over 13, that's meaningless. Nobody knows what that means. You need to have an angle in here. Okay? So don't write a trig function without its argument. Okay, we'll leave it here, and in the next video we'll talk about how to do more things with right triangle trigonometry.